All right, so this question comes from section 3.1, and it says consider the function f of x is equal to 3x squared minus 30x minus 6. And it says for us to determine, without graphing, whether the function has a minimum or maximum value. So to answer part A, to determine if you have a minimum or maximum value, you're going to look at the A value. And if the A value is greater than 0, well, that would mean that when you graph your function, it would be a parabola shape and it would open upward, meaning it would have a minimum value. And if your A value is negative, so A is less than 0, then when you graph your function, your parabola is going to open downward like this, and it would have a maximum value. So in this particular case, when I look at this problem, remember that our function, the basic quadratic function, looks like this. And so my function in this problem is 3x squared minus 30x minus 6. And so the A value is 3. It's the coefficient on the x squared. So since A is 3, that's a positive number, it's greater than 0, then I'm going to say that this function has a minimum value, because it will have this look to it, not this. And so then I'll move on to part B. And in part B, it says we'll find the minimum or maximum value. So we are going to be looking for the minimum value and determine where it occurs. So let's take a look at that part of the question. So this is my function. Let me rewrite it here. And if I want to find the minimum value, it is going to be that vertex. So in order to find the vertex, I can find the x coordinate by taking the opposite of b over 2a. This will be at where it occurs. So I'm going to say occurs at here. The minimum value will be the y coordinate, and that will be found by taking the function and plug in what we find here. So in this function, the a is 3, the b is negative 30, and the c is negative 6. So I'm going to plug in, so let me write those down. A equals 3, b equals negative 30, and c equals negative 6. So substituting those values into the opposite of b over 2a, it would be the opposite of negative 30 over 2 times 3. So I would get positive 30 over 6. So it would occur at 5. So, and then I would take that value now, and that's my x coordinate, and I would plug it in to the function. So I would say f at 5. And so my function was 3 times x squared minus 30x minus 6. So let's plug in the 5. Now, doing this calculation, what you could do is just put this in the calculator. Otherwise, we have to remember to follow the order of operations. So the first thing we do is square the 5. We would have 25. And then we would do multiplication. So 3 times 25 is 75. 30 times 5 is 150. And so I would end up with going from left to right, negative 75 minus 6, or negative 81. So this would be the minimum value. So in the MyLab Math, it will say the minimum value is, and it leaves a blank. And then it says it occurs at x equals blank. So the minimum value is, you're going to put in here the y value. And the y value of the vertex would be negative 81. And then where it occurs at would be at 5, at x equals 5. So that means that if we were to graph this, if this was 5 on the x, and here's negative 80, so it would just be past that. So this would be the vertex point. And also, we don't know the x-intercepts, but we know c, and c was 6. So maybe 6 would be, let's say, about here. So I don't know the vertex point, the x-intercepts, but I do know the vertex, and I know the y-intercept. I know that any quadratic has this U shape, so it would look something like this. And I know that the lowest it's going to go on the x-axis, on the y-axis, apologize, is negative 81, and then everything goes upward. So then I can answer the last question, which says identify the domain and the range. Well, for all quadratics, the domain is negative infinity to infinity. It's all real numbers. The range, the lowest this one goes, this has a minimum value occurring at 5. So the lowest it goes is negative 81, and then it continues upward forever. So to infinity. And I would put a bracket here because it has a point here. So it includes negative 81, and then everything above it. And so that's how I'd answer part C, which asks for the domain and range. Now to verify this, we could bring over the graphing calculator. So let's do that too. So I went back to my original function, and I hit the y equals key, and I entered it in here. Now just to verify that I have everything correct, I can verify the graph by hitting graph. But if I hit the graph, notice I don't see that parabola, because remember, the y minimum, it occurred at negative 81. So what I have to do is I have to go down and I have to adjust my y minimum to below negative 81. So let's do negative 85. And now hit graph. And oh, here I see it. And then take a look. About 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sorry, I was off. And I look, that looks to be where you see the minimum. So you can kind of get an idea of the domain and range by looking at the graph on the calculator too. And if you hit second table, you can also view those points. And I see 5, negative 81 is on there. And I see that the lowest y value is negative 81. No matter if I go this way, the y values get larger. And if I go this way, the y values get larger. So the lowest point occurs at 5 when x equals 5 at negative 81. So that is another way to verify what you did by hand on here. So when you put it in there, make sure that when it asks for the minimum value, you're giving the y value of the vertex, and when you are giving where it occurs at, you give the x value. And that's how you do that type of problem from chapter 3.